Welcome back. Let's look at the last example problem in this topic. It's a problem on Catis. It's called the Disastrous Downtime. So you can read the problem on Catis. This problem is actually used in one actual programming contest. So it will be one of easier problem in any contest at that level. But nonetheless, it's an actual contest problem. So here's the problem statement. So you are given n requests that you need to serve. Each request will start at some time, which is given, and then every request will last 1,000 milliseconds. And you're also given a number k, which is the maximum number of requests one server can handle concurrently. So if we have more requests, then you need more servers. So the question asks you to compute what's the minimum number of servers that are needed so that all these requests can be handled adequately, so that you can avoid the downtime. So let's look at the sample input. We have 7 requests, and each server can handle two requests concurrently. So the first request comes at time 1,000. And because it lasts 1,000 milliseconds, it will end at time 2,000. And the second request come at 1,010. Third request come at 1,500. The fourth request come at 1999. So at the time 1999, or rather immediately after it, we have 4 active requests. All 4 requests are active. So we need the 2 server to be able to handle that, because each server can only handle 2 requests. Now at time 2000, a 5th request come along. So does that mean we need the 3 servers because we have 5 requests? So that's not the case, because at time 2000 sharp, the first request finished because it only lasts 1,000 milliseconds, and then the 5th request starts. So we still only have 4 requests that are active. So similarly, at time 2010, we have the second request is finished, and then we had a new request. So we still have these 4 requests that are active. And then at time 2500, then this request is also no longer active. We only have 3 requests active. And then at time 2999, we have this request finished, and then this request active. So the most we can have of a number of concurrent requests is 4. So then that means we only need 2 servers to be able to handle it. Yeah, so you can think about how you would implement it. And in fact, I encourage you to start writing the code, to try the code yourself, solving it before going on. I mean actually writing the code to solve it, because if you think about it, it's not that hard. But if you try to simulate it, depending on how you do it, the code can get quite tricky. So I strongly encourage you actually try yourself, submit the code, and see whether it passes before going on. So the key insight is we just need to keep track of the active number of requests at any time. And this number can be changed by 2 kinds of events: the starting of a request and the ending of a request. So when a request starts, then the number of concurrent requests will add 1. When the event finishes, the number of total active requests will subtract 1. So then we can sort of represent each event as a time, and then whether it's a +1 or -1. And then we just sort all these events based on time. And then we essentially have a difference array. So we essentially have the array of that have enough information about the number of requests at every time, but it's sort of storing the difference, how this changes. So then we just need to go through the array and then keep updating the number of requests, and then we can use that information to figure out what number is the maximum number of requests that's needed. So here is a sort of representation of that. So the first request generates 2 events. one have 1000 plus 1, and one have a 2000 minus 1. So these two kind of purple color corresponding with the first request, and then two blue color correspond with the second request. The two green color, the third request, and so on. So I didn't color the rest of them. So then if while we scan through this event and then just keep adding this number we see to the array, we will, at this point, we will get a number 4 at 1999. And then at 2000, because we need to do subtract 1 first and then do plus 1, because at this time the event ended. So if we do that, then we will see the maximum number of concurrent event is also 4. So by keep going through the event and then adding it up, we get the total number of active events. So this is the solution code in Java. It's fairly straightforward. So we create a T is the event array, which has 2 times n events when there are n tasks. And each event is described by 2 numbers, time, and whether it's a +1 or -1. And the next loop just reading the time, and then creating events in this array. So every new time will create 2 events, j and then j plus 1. So I use this j index, and incrementing after creating each event. And this is a starting event. So this is a starting event, starting time and +1, and finishing time and -1. So after this, we use this sort code that is not a standard library that I wrote it myself. It's just sorting 2D integer array first by comparing the first element. And if the first element is the same, then compare based on the second element. So which is exactly what we want, because for 2 events that are at the same time, we want the -1 going first. So after sorting, we will just go through all the events, and then we'll just adding this number to the adding whether it's +1, -1 to m, which keep track of the number of concurrent tasks or requests. So then this just checks whether we actually need more servers. So if it's greater than this, then that means we need 1 more server. Since each of this loop, this m can only increment by at most 1, so then adding 1 to answer will be sufficient. So you can do this in other ways. You can also compute the max of the number of requests and then compute the answer at the end.